Hi guys, today we're going to be looking at Cambridge IGCSE Additional Mathematics, October-November 2022, paper 2-2. So we're going to start now. First question is about simultaneous equations. So we have two equations here. We can call it 1 and 2. So from 1, we can rearrange the equation and have x equals to -4 minus 5y. So this we can name it as the third equation. So we can sub 3 into 2. So we have 3y minus y times -4 minus 5y equals to 6. So we would have 3y plus 4y plus 5y squared equals to 6. So we rearrange it to get 5y squared plus 7y minus 6 equals to 0. So now we can factorize the equation. We would get 5y minus 3 and y plus 2 equals to 0. So now we know that y is equals to 3 over 5 and y is equals to -2. So now we calculate for the value of x. So x is -4 minus 5y. So we have -4 minus 5 times 3 over 5, and we would get a -7. And for the second y value, we have x equals to -4 minus 5 times -2. So this would give us a 6. So we have two set of values, which is this and this. So we're done for question 1. Question 2. Solve the equation of 4e to the 2x minus 3 equals to 7e to the 5 minus x. Okay, so we gotta find what the x value is. So we can group the exponential together and the coefficient together. So we have e to the 2x minus 3, and we bring this to the left hand side. So we have over e to the 5 minus x. So now the right side is left with 7 over 4. Okay, so we can make this into just one term. So we have e to the 2x minus 3 minus 5 minus x. Because this is a divide, right? So we minus the indices. So for the right side, it's still 7 over 4. And we simplify the index. We have e to the power of 3x minus 8 equals to 7 over 4. So now we can write 3x minus 8 equals to ln 7 over 4. Okay, so now 3x would be equals to ln 7 over 4 plus 8, and x would be equals to 1/3 of ln 7 over 4 plus 8 over 3. Question 3. So we know that a and b are constants, and the normal to the curve y equals to a over x plus 3x minus 2 at a point where x equals to 1 has an equation of y equals to -1 over 4x plus b. So we know that the gradient of the normal is negative 1 over 4. Find the values of a and b. Okay, so since we know that the gradient of the normal is 1 over 4, we know that the gradient of tangent should be 4, right? And we can differentiate this equation to find for the value of a. So first, we do differentiation. So dy over dx equals to negative ax to the negative 2 plus 3. And when x equals to 1, dy dx equals to 4. So negative a times 1 to the negative 2 plus 3 equals to 4. So 3 minus a equals to 4, a equals to negative 1. So this is the value of negative 1. And now we need to find for the value of b. So we know that the curve and the normal would be intersecting at the point x equals to 1, right? So we can just find for the intersection point. So we know that they intersect. So we use the intersection point method. So when x equals to 1, the y value would be negative 1 over 1 plus 3 times 1 minus 2. And this would be 0. And for the normal, the y value should be the same. So we have y equals to negative 1 over 4 times 1 plus b. And we would have negative 1 over 4 plus b. But because they intersect, so these two values should be equal. So we have negative 1 over 4 plus b equals to 0. So b would be 1 over 4. And we're done. Question 4. Solve the equation of log base 3 11x minus 8 equals to 1 plus 2 over log base x 3. Okay, so we have two log terms, but they have different bases. So in order to solve this equation, we need to change them to the same base. And the formula to change the base would be this. If we want to change this into base c, let's say, we would need to use this formula. So this is our formula to change the base. Okay. And to apply this to this question, let's change it to log base x. Alright. So the first term, log base x 11x minus 8 over log base x 3 equals to 1 plus 2 over log base x 3. And let's multiply the entire equation by log base x 3. So we have log base x 11x minus 8 equals to log base x3 plus 2. And now we can group the logs together. So we have log base x 11x minus 8 minus log base x3 equals to 2. So this is a minus. So we can have this divided by this. So we have log base x 11x minus 8 over 3 equals to 2. So we would have 11x minus 8 over 3 equals to x squared. So move the 3 to the right side. We will have 11x minus 8 equals to 3x squared. And we rearrange it to get a quadratic equation, which is 3x squared minus 11x plus 8 equals to 0. Factorize it, we would have 3x minus 8 and x minus 1 equals to 0. So x would be 8 over 3 and x would be 1. And look at the question. We need x more than 1. So this would be rejected and 8 over 3 would be the only answer. Question 5. Find the x-coordinates of the points of intersection of the curves y equals to 7x cubed minus 7x squared minus 17x minus 4 and y equals to x cubed minus 2x squared minus 4x minus 16. So that means we need to equate these two equations together. So we have 7x cubed minus 7x squared minus 17x minus 4 equals to x cubed minus 2x squared minus 4x minus 16. So simplifying this, we would get 6x cubed minus 5x squared minus 13x plus 12 equals to 0. So by right, we cannot use the calculator. We need to try and error to find for the solution of x. But to save our time, we can use the calculator and we can see that one of our answers is actually x equals to 1. So to show the examiner that we actually didn't use the calculator, we need to show them that we actually trial and error. So by trial and error, we let x equals to 1. And we prove it to them that 1 is actually one of the solution. So we sub x equals to 1 inside this equation. And we show them that we actually get a 0. So this equation over here, this expression over here is equal to 0 when x is equal to 1. Hence, x minus 1 is a factor of the expression. So now we can divide this equation, this expression by x minus 1 to get the other solutions for x. So we have 7x cubed minus 7, not this one. 6x cubed minus 5x squared minus 13x plus 12 divided by x minus 1. Okay, so we use long division to find for the other factor of the expression. So our goal is to take the quotient here. We take this quotient, multiply by x minus 1 to get this expression. So first step, how do we find 6x cubed? So we need a 6x squared times x to get 6x cubed, right? So 6x squared is the first term that we need. So now 6x squared minus times minus 1 would be minus 6x squared. And we take negative 5x squared minus negative 6x squared. So minus minus plus, we have x squared minus 13x. And same thing, we need to take the term here. We need to use this term, multiply by x to get x squared. So we would need an x here. So x times x is x squared. X times negative 1 is negative x. And negative 13x minus negative x would give us minus 12x plus 12. And this term times x should give us negative 12x. That means we need a negative 12 here. So negative 12x plus 12. So we found the other factor of this expression. So we have 6x cubed minus 5x squared minus 13x plus 12 equals to 0. And we found out that x minus 1 times 6x squared plus x minus 12 is equals to 0. And we factorize this part as well. So x minus 1 remains the same. And factorizing the quadratic expression, we have 2x plus 3 and 3x minus 4 equals to 0. So x would be equals to 1, negative 3 over 2, and 4 over 3. Question 6. We need to form a 4-digit code using 4 different numbers selected from 2, 3, 4, 5, 6, 7, 8, and 9. And we need to find how many possible codes there are if the code forms a number that is odd and greater than 5,000. So from this, we can actually separate it into 3 different situations. So we have 4 digits, 3 different situations. So the first situation, because it's odd and greater than 5,000, if we choose 5, 7, and 9 as our last digit, it's a bit hard to know which one we need to put in the first number. And that's why we need to separate it into 3 situations. First situation is when the last digit is 3 and the first digit can be 5, 6, 7, 8, or 9. Second situation, we have the last digit as 5, 7, or 9, and the first digit is also 5, 7, or 9. Last situation, we have the last digit as 5, 7, or 9, and the first number as an even number, which is 6 or 8. Even number that is more than 5. Yes. So if we split into three different situations, it would be easier and we can make sure that there's less mistake made. So first situation, we choose from 5 numbers. So 5p1 times. So we use one number here and another number here. So in total, we have 8 numbers. So since we already used 2 of our numbers, we have 6 numbers left. And we need to choose it for 2 slots. So 6p2 would be the first situation. And this gives us 150. Second situation, we choose from 5, 7, 9, and we put them into 2 different slots. So we choose from 3 numbers and we put them into 2 different slots. So 3p2 times, like what I said, we already used 2 numbers here. So we have 6 more numbers left to put it into 2 different slots. So 6p2 as well. And this would give us 180. Third situation, we choose from 6 and 8 for the first slot. So we have 2p1 times, we choose from 5, 7, and 9 for the last slot. So 3p1. And lastly, we have 6 more numbers left for 2 more slots. So we have 6p2. And this would give us 180. So in total, we have 150 plus 180 plus 180. And this would give us 510. So in total, we have 510 possible codes for part A. Part B. We need a number that is greater than 5,000 with a last digit that is prime. So let's list out the prime numbers that are in this list. So we have 2, 3, 5, and 7. So we have 4 prime numbers, and we can see that 2 of them are actually contributing to this fact. So to have a number greater than 5,000, the first digit should be 5 or more, right? So these two numbers can actually be used in the first digit. So same thing, we would split them into 3 situations. So we have 4 numbers. And first situation, we have 2 or 3 as our last digit. So for the first digit, we can simply choose from 5, 6, 7, 8, or 9. Second situation, we have 5 or 7 as our last digit. And the first digit, we also need to choose from 5 or 7. And third situation, we have 5 or 7 as our last digit. And the first digit, we cannot choose from 5 or 7 anymore. We need to choose from 6, 8, or 9. Okay, so these are all the possibilities that we can have. So the first situation, we choose from 5 numbers for one slot. So 5p1, and we choose from 2 numbers for the last digit, which is 2p1 as well. And for the middle numbers, same thing, we have 6 numbers left because we already used 2. So we have 6 numbers left, and we choose for 2 slots. So 6p2. And this would give us 300. Second situation, we have 2 numbers to choose from for 2 slots. So 2p2, or you can write as 2 factorial. It's the same thing. So let's use 2p2 here. And for the middle numbers, we have 6p2. And this would give us 60. Third situation, we choose from 3 numbers for the first slot. So we have 3p1. And we choose from 2 numbers for the last slot, which is 2p1. And lastly, for the middle numbers, we have 6p2 as well. And this would give us 180. So in total, we add them up together, 300 plus 60 plus 180, and we would end up getting 540. Question 7a. Show that sine x over 1 minus cos x plus 1 minus cos x over sine x equals to 2 cosec x. So for this question, we need to prove that. So we can start proving from the left hand side. We make them to have the same denominator. So for the first term, we multiply it by sine x. So this is how we should do it to make them have the same denominator. And the second term, we multiply it by 1 minus cos x. So the numerator and the denominator. So from this, we can get our numerator as sine square x plus 1 minus 2 cos x plus cos square x. And for the denominator, we would have sine x times 1 minus cos x. So we can leave it like this first. We simplify the numerator to see that. We can see that x squared plus sine square x plus cos square x is actually equals to 1, right? So we can have 1 plus 1 minus 2 cos x over sine x times 1 minus cos x. So for the numerator, we can actually factorize the 2 out, and we would have 1 minus cos x. Denominator stays the same. And now we can see that we can actually cut this 2 off, and we're left with 2 over sine x. So 1 over sine x is cosec x. So we have 2 cosec x. and this is exactly equals to this. So the left hand side is equals to the right hand side. Proven or shown. Part B. Hence solve the equation of this. So we can see that the left hand side of the equation is actually the exact same thing as this. So since we already proven that the left hand side is equals to the right hand side, we can actually write this into 2 cosecant x, and the right side remains as 3 sine x minus 1. And now we can start solving the equation. So 2 cosecant x is actually 2 over sine x, and we have 3 sine x minus 1 on the right side. So we multiply the whole equation by sine x. So we have 2 equals to 3 sine square x minus sine x, and 3 sine square x minus sine x minus 2 equals 0 would be our new quadratic equation. So we have, to factorize it, we have 3 sine x plus 2 and sine x minus 1 equals 0. So sine x is equals to negative 2 over 3, and sine x is equals to 1. So for this situation, we have the base angle as 41.8, and since it's a negative number, this is sine, tangent, cos. This means that everything here would be positive, and for sine, this would be positive, this two parts would be negative. So since this is a negative number, we need our angle to be here, these two parts. Okay? We need our angle to be in the third and the fourth quadrant. So for the third quadrant, we have 180 plus 41.8, so we get 221.8 degrees. And for the fourth quadrant, we have 360 minus 41.8, so we have 381.2 degrees. And for the second situation, we have sine x equals to 1, which is a positive number. So we have the angle in these two quadrants. So when sine x is equals to 1, the base angle would be 90 degrees. So no doubt x is only here. So x is only 90 degrees for the second situation. So we have 3 solutions for x in this question. Question 8. We have a volume of a cylinder with radius r and height h as pi r square h, and the curved surface area is 2 pi r h. For sphere, the volume is 4 over 3 pi r cubed, and its surface area is 4 pi r squared. See, the 4 pi r squared and the 4 over 3 pi r cubed is actually for a sphere, and this is obviously a hemisphere. So we gotta take note of that to avoid any careless mistake. So for this model over here, they tell us the total surface area is 300 cm squared. So for part A, we need to find the expression for h in terms of r. So we have this fact over here, so we can calculate the surface area. So first, we need to find the surface area of the hemisphere. So this area over here. Second is the curved surface area of the cylinder. And lastly, the surface area of the base of the cylinder. So first one we have, see, because this is 4 pi r squared, is for the whole sphere. So for a hemisphere, it would just be half times 4 pi r squared, which is 2 pi r squared, plus the curved surface area here is given as 2 pi r h. So plus 2 pi r h plus the circle at the bottom of the cylinder, which is pi r squared. So all this add up to 300, and let's simplify the equation. So we have 2 pi r h equals to 300 minus 3 pi r squared, and we need to make h the subject. So h is equals to 300 minus 3 pi r squared over 2 pi r. And this would be the expression for h in terms of r. For part B, show that the volume V of the object is 150 r minus 5 over 6 pi r cubed. So if you look closely, there is no h term over here, right? That means at first we would obviously have our h term because the hemisphere is half times 4 over 3 pi r cubed, which is 2 over 3 pi r cubed, plus the volume of the cylinder, which is pi r square h. But we need to sub this equation into the h value here. So we have 2 over 3 pi r cubed plus pi r square times 300 minus 3 pi r square over 2 pi r. And let's simplify it. We would get 2 over 3 pi r cubed plus 150 r minus 3 over 2 pi r cubed. So all this adds up to 150 r minus 5 over 6 pi r cubed, which is exactly what the question wants. Part C. Find the maximum volume of the object as r varies. So we have an equation of V and R over here. So to find the maximum volume, we need to differentiate this equation. So we have V equals to 150 R minus 5 over 6 pi R cubed. So we need to differentiate this equation in terms of R. So we have dV over dr is equals to 150 minus 5 over 2 pi r squared. And we equate this whole thing to 0. So we have r squared equals to 60 over pi, and r would be plus minus 60 over pi squared. So r is plus minus 60 over pi. So we can sub the r values back into the v to see which one is the maximum volume. So for r equals to positive 60 over pi, we have 150 times 60 over pi minus 5 over 6 pi times 60 over pi cubed. So this would give us 437 cm cubed. And for r equals to negative 60 over pi, we have v equals to 150 times negative 60 over pi minus 5 over 6 pi times negative 60 over pi cubed. And this would be equals to negative 437 cm cubed. And volume cannot be a negative value, so we need to reject this. And we know that 437 would be the maximum volume. Question 9. It's a triangle question. So we have triangle ABC with area 2 sub 5 over 3 and angle A is acute. Find the exact value of sine A. So since we have the fact that the area is 2 sub 5 over 3, we can use the area of the triangle. We can use that formula. So we have half times the two sides, sub 5 minus 1 and sub 5 plus 1. Sine A equals to 2 sub 5 over 3. And now we need to expand the brackets. So half times 5 minus 1 sine A is equals to 2 sub 5 over 3. So 2 sine A is equals to 2 sub 5 over 3, and sine A would be equals to sub 5 over 3. Part B. Find the exact value of cos A and hence find the exact value of x. So let's do it one by one. We first find for the value of cos A. How do we do that? So from part A, we know that sine A is sub 5 over 3. So we can actually draw a right angle triangle, and let's call this angle A. So sine A is sub 5 over 3, and sine A is the opposite over the hypotenuse. And this is the opposite, this is the hypotenuse. So we know that the ratio should be sub 5 and 3 over here. And we can use the Pythagoras theorem to find for the adjacent. So we have adjacent equals to 3 square minus sub 5 square, and square root the whole thing. So this would be equals to 2. So now we know that this has the ratio of 2. And therefore, cos A would be adjacent over hypotenuse, and it would be 2 over 3. And now we can find for the value of x. So we can use the cosine rule. So cosine rule states that a squared equals to b squared plus c squared minus 2bc sine a. Sorry, cos a. My bad. This would be our cosine rule. So we can call this side A, call this side B, and C, because the sides are always the opposite of the angle A. So angle A corresponds to side A in the opposite, angle B has the side B at the opposite, and angle C has side C at the opposite. Okay, so now we can sub in the values. So a squared would be x squared, and b squared would be sub 5 minus 1 squared, and c squared would be sub 5 plus 1 squared minus 2. B would be sub 5 minus 1. C would be sub 5 plus 1. And cos A would be 2 over 3. So now we simplify the right hand side. We get 5 minus 2 sub 5 plus 1 plus 5 plus 2 sub 5 plus 1 minus 2 times 5 minus 1 times 2 over 3, and all this adds up to 12, and this part is 16 over 3. So this would be 20 over 3, and x would be sub 20 over 3, or negative sub 20 over 3. But because x is actually the length of BC, so length cannot be a negative value, so this is rejected. And sub 20 over 3 would be 2 sub 15 over 3. Part C. Find the exact value of sine B. So for this one, we can either use the formula for area of the triangle, or we can use sine rule. And since we already used the formula for area of triangle in part A, let's try using the sine rule for part C. So sine rule states that the sine B over side B, the length of B, is equals to sine A over the length of A. So we can start subbing in the values. B would be sub 5 plus 1. Sine A would be sub 5 over 3, as what we found in part A. And A would be our x value, which is 2 sub 15 over 3. Okay, so now sine B is equals to sub 5 over 3 divided by 2 sub 15 over 3 times sub 5 plus 1. And we can use the calculator to calculate this. We have sub 3 over 6 times sub 5 plus 1. So now we get sub 15 plus 3 over 6. So this would be our sine B value. Question 10a. A geometric progression has third term 4.5, so this is T3, and sixth term 15.1875, so this would be T6. Find the first term and the common ratio. So we can list down the equations that we have. So AR squared equals to 4.5 and AR to the 5 equals to 15.1875. This is the first equation. This is the second equation. So now we can do the simultaneous equation. We can use the second equation to divide to be divided by the first equation, and we would get AR to the 5 over AR squared equals to 15.1875 over 4.5. So for this one, since A is a constant term, it's not equal to 0, so I can cancel out. And R is also not 0. It can't be 0. If not, it wouldn't be a geometric progression. So I can simplify the indices of R. So this would give me R cubed. And the right hand side, type it into the calculator, I would get 27 over 8. And R would now be, so 27 over 8 is actually 3 over 2 cubed. And R would be 3 over 2. So let's find for the value of A now. So A times 3 over 2 squared equals to 4.5 according to the first equation. So I move this to the right hand side. I would get A equals to 2. Part B. Find the sum of 10 terms of the progression starting with the 16th term. That means they want the sum from T16 all the way to T25. From the 16th term to the 25th term. This would be 10 terms in total. So how do we do it? We take the sum of the first 25 terms minus the sum of the first 16 terms. 15 terms. Because we want to include T16. If we minus the sum of the first 16 term, we would cancel out the 16 term as well. So S15 should be the correct method. So now we just sub the values into the formula. 2 times R would be 3 over 2 to the power of 25 minus 1 over 3 over 2 minus 1 minus 2 times 3 over 2 to the power of 15 minus 1 over 3 over 2 minus 1. So if we type this whole thing into the calculator, we would find that the nearest integer would be 99,253. This would be the nearest integer. Question 11, which is also our last question over here. We have the coordinates of point A and B with A as -5 and 6 and B as 4 and -6. The point C lies on the line AB and it's between AB such that AC over CB is 1 over 2. That means if you have a line AB over here, this is our A, this is our B. A is -5 and 6, B is 4 and -6. So C lies over here, maybe a bit more to the right. This will be our C, such that AC to CB is 1 to 2. This is the ratio. So find the coordinates of C. So we just have to plug it into the formula. So we have -5 times 2 plus 4 times 1 over 1 plus 2. And 6 times 2 plus -6 times 1 over 1 plus 2. And this would give us -2, 2. So we know that the coordinates of C would be -2, 2. Part B. The line CD is perpendicular to AB, and find the equation of CD in the form of y equals to mx plus c. So this is our line AB, and CD would be perpendicular to the line AB, like this. So if it's perpendicular, we first need to find the gradient of line AB. So the gradient of line AB would be -6 -6 over 4 minus -5. This would give us a -4 over 3. And CD is perpendicular to AB. That means the gradient of CD would be 3 over 4. And now we can plug it into the formula. We have y equals to mx plus c. We know that C is for sure on the line CD, right? So we can use the coordinates of C. We have 2 equals to the gradient of line CD would be 3 over 4. So 3 over 4 times x, which is -2, plus c. So the value of c would be 7 over 2. So now y equals to 3 over 4x plus 7 over 2 would be the equation of CD. Part C. The length of BD is cert125. Find the coordinates of the two possible positions of point D. So now we don't know the coordinates of point D. Let D equals to x and y, because we don't know the coordinates, right? But we know that point D lies on this equation over here, lies on this line over here, and we know that y is equals to 3 over 4x plus 7 over 2. So now we can write y as 3 over 4x plus 7 over 2. Okay? And the other fact is that BD is cert125. And the coordinates of B, let me write it down, is 4 and -6. So now we just have to plug it into the equation, the formula for the distance of 2 points, which is the first point minus the second x point squared plus the first y point minus the second y value, square the whole thing, and square root the whole thing, equals to set 1, 2, 5. So now we can expand all these brackets. We have, also, since both of these are square root, right? So we can actually just square both sides, and the square root, we can just ignore the square root. Okay, so we have x minus 4 squared plus 3 over 4x plus 19 over 2 squared equals to 125. So now we expand the brackets. We have x squared minus 8x plus 16 plus 9 over 16x squared plus 57 over 4x plus 361 over 4 equals to 125. And we can have, we simplify it to get 25 over 16x squared plus 25 over 4x minus 75 over 4 equals to 0. We can divide this whole equation by 25 over 16 to make our lives easier. So we have x squared plus 4x minus 12 equals to 0. And factorize this, we can get x plus 6 and x minus 2 equals to 0. So x is equal to negative 6 and x is equal to 2. So for the first x value, we need to find for our y value. So y would be 3 over 4x plus 7 over 2. So 3 over 4 times negative 6 plus 7 over 2 would give us negative 1. And when x is equal to 2, we have y equals to 3 over 4 times 2 plus 7 over 2. And this would give us 5. So d can be negative 6 and negative 1, or 2, 5. So these are the two possible coordinates of D. And that's it for the paper.